Let us discuss about one of the most amazing and simple circuit which I was not taught in our high school or college. I had to see this being taught in Premier University in Europe. Let us begin. So, in this circuit, when the switch is on for a long time, you see the direction of current in the figure of each element of the circuit. After the inductance is fully charged, that is after the switch has been on for a long time, the inductance can be replaced by a simple wire of zero resistance to calculate the value of current. The current in wires can be calculated by a high school student. He or she will apply the simple old Ohm's law and calculate the value of I1 and I2. Now, my question for you is, what do you think the voltage will be across point A and B when the switch is switched off? You may like to pause the video and guess. Let me tell you in the next page. Let me keep the circuit from previous page so you see the difference. When we switch off, the battery part of the circuit becomes dead. Yet at that instant when the switch is off, the inductance springs to action, and it makes sure the current in the inductor remains the same. This is due to the famous Lenz law. A high school student who knows physics also knows this, but he may not be fluent to apply it. Anyway, now you know the circuit at the instant switch is off. Try its best to have the current I2 in inductance. Now, that means current across R1 is also I2. Let us find the voltage across A and B. A high school student will tell you that it is I2 times R1 from Ohm's law. The value of voltage comes out to be 5,000 volts, and, amazingly, it does not depend on inductance. You may note the polarity is reversed. So you have generated 5,000 volts from a 5-volt battery. Would you like to guess where it is used? Let us discuss in next page. The spark plugs, which is a must for motorcycle and cars running on gas, which is called petrol in many parts of the world. It works by making spark in the air in between 2 points. Or to say, you apply high voltage, that the air becomes good conductor of electricity. We know, as property of air, that we must reach about 3,000 volts per millimeter to make air a good conductor or generate the spark across the 2 points. From the simple battery and this magical circuit, this is how it is done. Same again with the flash of the camera. Flash is generated by making the gas in bulb as good conductor, which therefore needs high voltage. Just to say, you may have observed if you take too many flashes, you must wait some time before you take another flash photo. This is the time when inductor is charging. Just a last comment before I end this video. I have told you the role of inductor in creating Lenz law. I also need to tell you that the current flows because the inductance has stored the energy, and it is discharging from the moment the switch is off. How long it discharges depends on the size of the coil or the value of inductance. The current exponentially decreases, given by this formula. That is all in this video. I hope it has stimulated you in asking more questions. By then, till next time.